My name is Flora Vale. I am a product engineer on the analysis and geoprocessing development team out in Redlands. And this is my colleague, Tom Wason. He is a front-end developer on the ArcGIS Hub team. And this afternoon, we'll be talking to you about charts and custom visualizations beyond the map. I'll start by discussing the importance of data visualization, some little data viz theory, some do's and don'ts, how this all applies to spatial analysis, and how we've begun to implement this in ArcGIS Pro. And then I'll hand it over to Tom, and he'll tell you about the charting development that's coming out of the hub, and how you can leverage this to create your own custom visualizations, since this is the Developers Summit and all. So let's start here with the basics. What is data visualization? Well, simply put, data visualization is a graphical representation of data. It's the use of symbols as metaphors to represent quantities, categories, and amounts, allowing us to quickly make comparisons and intuit proportions, patterns, and relationships instead of having to calculate them in our minds. So here are some examples of the classics. You didn't think you were going to get through a data viz talk at a mapping conference without seeing a Jon Snow map, did you? Don't worry, I won't spend too long here. I think most of us are familiar with Jon Snow's work, but the reason that you see a Jon Snow map at every data viz talk is because it was truly transformative. In each of these examples, visualizing the data not only made it easier to process, but it actually uncovered insights that would have been virtually impossible to find without the visualizations themselves. So Jon Snow was able to pinpoint the outbreak of cholera by identifying a contaminated water pump. Florence Nightingale was able to show that epidemic disease was causing more British deaths than battle wounds during the Crimean War. Charles Minard elegantly incorporated several dimensions into one visualization, including time, location, number of deaths, and temperature, all in one visualization telling the story of Napoleon's march. And though not quite as historic, but nearly as iconic, Hans Rosling wowed the world with his animated visualizations of global life expectancy in his 2006 TED Talk. In summary, we visualize data to convert slow reasoning tasks into fast perception tasks, so that we can intuitively perceive relative differences instead of having to hold information in memory and perform mental calculations. This process of visual perception is pre-attentive. So that means that it happens automatically with virtually no effort, in contrast to attentive processing, which requires conscious effort and calculation. For example, if I were to ask you to identify the largest number on this slide, that would be kind of a tedious task, right? You'd have to do a lot of kind of mental memorization and sorting, and maybe you'd have to take out pen and paper. But in contrast, if I were to show you this slide and ask you to identify the largest value in this chart, you could do that immediately, right? You can find it instantly because the values are now represented as visual variables. In 1967, a French cartographer named Jacques Bertin published what has now become a fundamental reference in data viz theory called the semiology of graphics. And in this book, he describes visual variables and how they can be used to communicate data visually. So more work has been done on this since, but the original visual variables are still the foundation of most data visualizations. So those are position, size, shape, value, hue, orientation, and texture. In this visualization, we're perceiving relative length of the bars by comparing their position. So they all have a common start point, and their position communicates their endpoint. And many researchers agree that position is the visual variable that we are best at distinguishing, which really is why bar charts are so useful and ubiquitous. Of course, we could also use size, hue, orientation, or any of the other visual variables to make that text stand out. But not all visual variables are appropriate for every data type. Noah Alinsky, who is a thought leader in this space, put together this great table detailing the best practices for visual encodings. So for example, size is a good way to represent quantitative and ordinal data, but not appropriate for categorical data. Color can be a good way to represent categorical data, but only when there are few categories. So this is a really handy reference for understanding the different data types and how you can use visual variables to represent them. All of this is important to keep in mind because not all visualizations are created equally. Understanding how our eyes and brains perceive visual variables is key for effectively communicating through data visualizations. So let's go ahead and get this one out of the way. Pie charts, though beloved by many, are not the most effective way to represent proportions. Understanding a pie chart requires us to visually compare angles, which can be difficult to do, especially when there are many. So looking at these three charts, it's not immediately apparent which slices are largest in each pie. Of course, we could take time to figure it out. We could maybe bust out a protractor and do some measurements. But if we visualize these as bars instead, now we don't need any attentive processing. As I mentioned before, we're really good at perceiving length, so the bar charts make the differences immediately distinguishable. So what is worse than a pie chart? A 3D pie chart. There are whole corners of the internet dedicated to criticizing the misleading visualizations used in Apple keynotes. So if you look at this chart here, notice how the pie is tilted just so to make Apple's 19.5% market share appear larger than the 21.2% slice. So it's, we have a lot of responsibility here when we're communicating data visually to be accurate and to be honest. Okay, the donut chart may be a prettier version of the pie chart, but it's in fact even harder to decipher. So the angles have now been removed. So now we're left to compare arc lengths that don't have a common origin. And this is pretty difficult to do, especially when there are many arcs. And of course, 3D donut charts, please don't. All of these rules have exceptions. I'm not going to tell you that it's never appropriate to create a pie chart. But I am going to step out on a limb and say that it's never appropriate to create a 3D donut chart. Really, with very few exceptions, 3D charts are highly discouraged. While bar charts are one of the most dependable and easy to read visualizations, when drawn in 3D, they become harder to decipher. So which edge of that bar are we supposed to compare to the axis? The one in the front, the one in the back? Or what's hiding behind that bar over there? Nobody knows. So really, we could have, creating these charts in 3D added no value, and in fact just distracted us from seeing the real data by including a lot of extra chart junk, as Edward Tufte calls it. Another way to obscure the trusty bar chart is to remove its origin. So bar charts must always have a zero origin. Notice how in the example on the left, the preoperative value appears to be less than half of the postoperative value. But when we look at the correct chart on the right that has a zero origin, we see that the difference is much less severe. So since we're perceiving relative lengths as proportions, if you don't include zero, it's very misleading and in fact incorrect. So bar charts must always include zero. The next chart faux pas is to use lines to connect arbitrary categories. With few exceptions, lines should only be used to visualize change over something like time or maybe distance. Using lines to connect discrete categories, like states in this case, just doesn't make sense. So again, a bar chart would have been a lot more appropriate for this type of data. And here is our last chart crime of the day. There's this great website called WTF Viz where people submit misleading, incorrect, or otherwise terrible visualizations, which is a lot of fun to look at. And this one is a great example. So at first glance, it looks like crime has decreased significantly. We're looking at homicides over time. But if you take a closer look, each one of these data points represents 1 year's worth of data until the last two. The second to last one is from it's just 6 months of data from June to July to June, and then the other one is August to, it's small on my monitor here, but if I increase this. Yeah, January to June, so about 6 months of data, and the last one, July 1st to August 3rd. So how can we compare full years of data to 1 month of data and then honestly tell people that crime has been decreasing over time? It's really hard to believe that this mistake was made unintentionally. But again, just really important to keep in mind that we need to be accurate and honest with our visual representations of data. So limiting misleading or inappropriate visualizations while making it easy to create useful ones is a delicate balance. In designing the charting UI and UX in ArcGIS Pro, we try to incorporate some data visualization theory into the parameter options and provide smart defaults to help guide users to effectively visualize their data. We've made it as difficult as possible to create bad charts while making it as easy as possible to create good ones. And this is a delicate balance, right? Because we want to give people who really have a great understanding of their data and who understand data visualization theory the flexibility to make exactly the chart that they need. But we don't want to give people so much rope so that they can hang themselves. So we want to keep these charts, like for example, we're not going to let you create a bar chart without a zero origin because I really can't think of an example where that's appropriate. We don't have pie charts in Pro at the moment. Not saying that they're never appropriate, but we really recommend that you use bar charts instead or stacked bars. So we kind of had to try to guide our users without putting in too many limitations so that they could accomplish their tasks. And really, we focus this all on the spatial analysis workflow. So charts are in Pro to support our spatial analysis users and their spatial analysis workflows. So in deciding what types of charts to include, we really focused on this analysis workflow, which includes exploring your data, getting to know your data, interpreting your analysis results, and communicating your findings. So we need to explore our data before we start any analysis. And once we have analysis results, we need the aid of visualizations to understand the analysis results. And then we also need the aid of visualizations to communicate our results to decision makers or to the public. And we do this through visualizing distributions in frequency, category comparisons, relationships and correlations, and change over time or distance. So most of us are familiar with the importance of visualizing our data spatially to look at spatial distributions, but distributions in data space are also really important, right? So looking at a histogram of your data, is your data normally distributed? Is your data skewed? So many analyses actually assume that your data is normally distributed. So if you can't really visualize that before you start your analysis, you might be at a loss. And understanding if your data is normally distributed helps you understand if those summarizing characteristics, like mean, for example, is actually representative of your data. So if your data is not normally distributed, then the mean of your data is not going to be the mode. With a normally distributed data set, the mean, median, and mode should be about the same, which means that most of it falls in the middle near the average, and less of it falls on the tails, far from the average. But sometimes if your data is not normally distributed, the mean is not representative of the data set. For example, there is this joke by a comedian that I really like called Bo Burnham where he says, The average person has 1 fallopian tube. So, of course, some people do have 1, but most people have either 0 or 2. But if we did an average, we would get the number 1. And if we were just going to try to see if that average is representative of the population, then we'd be wrong, unless we made a histogram and we would see that it would be a bimodal distribution like this. So we would know that that mean was not representative. So looking at the distribution of your data, very important. We can do that through histograms. We can also do that through box plots. And box plots are a great way of comparing distributions to each other across categories or across different data sets. We can also compare categories through bar charts. So we can summarize amounts and counts. And we also have the ability now to have stacked bars to show those part-to-whole relationships and compare those across categories. To look at relationships, we have scatter plots, bubble plots, and the scatter plot matrix. So we can explore correlations and relationships. And then to look at change, we have line charts, and in the last year we've added the data clock, which helps us look at not only trends but also seasonality and cycles. So I think it's safe to say that given where we are, most of us understand the value of visualizing data on a map. But there are some instances when a map could really benefit from a companion visualization. And state maps are a great example of that. Please be assured, I will never tell you not to create a state map, but state maps on their own can be a little frustrating to me. Because usually in the case of state data, the location of the state is not what's important to us. They're really just categories that we're trying to understand. But since they do have a location, they're often presented to us in a map, which again is great, but where California isn't really the information that we need. And usually when we put things on a map, it's because we're trying to understand spatial relationships. But we know that states are very politically chosen, and they're not really necessarily related to what's nearby. So in this case, we can tell which states have the highest values, even though some of them are pretty small and hard to see. But within those highest values, we can't tell which one is the highest. But if I were to create a bar chart, we can immediately tell that I believe that it's in Nevada is the tallest bar. And if I were to sort those bars, even easier to tell. So now we can have both of these visualizations together to help us understand this data a little bit better. And those relative differences also between the different color ramps. Another example of when a map alone isn't the best option is when we're looking at time. So a lot of times with maps, we'll have different snapshots of time and kind of compare those, which is one way of doing it. There are some different analysis techniques that allow us to kind of digest temporal trends and then present those on a map. But we can also use charts. So a line chart is a great example. The data clock is another one that I'll show in a bit. But here is a kind of an interesting way of looking at time. So I've actually split this up by hour of day, and the lines are each representing one day of the week. And these are looking at fatal car accidents. So the two pinkish purple lines are the weekend, and you see that there are more car accidents around 2 a.m. on the weekends. But then the weekdays, we see a different pattern, which is more of like rush hour in the morning and then a bigger surge in the rush hour in the afternoon. So understanding this trend temporally wouldn't really be doable with just a map, looking at those different days of week and time of day components. And the last example here that I'll show is this problem called Anscombe's quartet. So if we look at these 4 different data sets, they all have the exact same mean, median, and R squared, and standard deviation, I believe. So if we're just summarizing these data sets, we would think that they're all very similar. All of their descriptive stats are the same. But if we visualize them using scatter plots, we can see that they're all actually quite different. Some are kind of linear, some are very skewed by one outlier, some have a more of a curvature shape. So again, important to visualize your data to really understand what's going on there. So let me jump into Pro and show you a little bit of this in action. I'm going to start here with this data set that I have from CMS, and it's looking at Medicare beneficiaries by county and describing some different health characteristics, like the percent of the population that's had a heart attack, diabetes, how much we're spending per beneficiary, et cetera. And so looking at the table by itself, of course, we're not really going to make much sense of this. And the first thing that I do always is to put that data on a map. And now we have a better understanding of the spatial distribution of this data. But again, I want to know more. So the first thing I always do with something like this is create a histogram and take a look at, let's see, maybe the average HCC score, which is a measure of the health of the population. So I see that it's pretty normally distributed. I can overlay a normal distribution line over here, and I can interact with this chart. So I can look at the places with the highest scores and have those select on the map. I can also, if I were to create another chart, let's say of states. So this is county data, but I can summarize by state and look at the mean, let's see, depression rate by state. So now I can interact with both of these charts and the map at the same time. I can select these with the highest values, see where they fall on the map, see where they fall on the other chart. Something that was important to us was that these charts be able to be created through ArcPy, because we started including charts in Pro not only to help you explore your data like I've been doing, but also to help you understand your analysis results. So now many geoprocessing tools will actually output charts with your output layer through Python. So we can do that through the tools, but we can also just do that through a little scripting. So I'm going to copy this here. Really, we just point to our project, our map, and our layer, give our chart a name, and then describe, I'm going to make here a scatter plot, comparing the HCC score to the percent of the population with diabetes, and then add that to my layer. So if I go over here to my Python window and paste this, we'll create a scatter plot, and that will be added to my layer here. So my scatter plot, and I can open that up and take a look. We've also added the ability to create a bubble plot recently, so I can make the symbols proportional to a different variable. And I'm going to jump over to this car crash data quickly to show you these charts in action. So the line chart that we have here, looking at the car crashes from 2010 to 2015, we see that seasonality throughout the year. And you also see here that we have this time binning options. So we choose a default binning interval for you. Right now it's at 4 weeks. We could change this to maybe 2 weeks if we wanted a more coarse pattern, for example. But the tool is going to look at the distribution and density of your temporal data and create those intervals for you. And you don't have the ability to create some intervals with more time in them than others, like we saw in that bad chart in the beginning of the talk. So one of those ways that we tried to impose good data viz theory into our visualizations. And then here are some examples of data clocks, which show that seasonality. This one is years split up by months, and this one is years split up by weeks. And then the last thing I'll show you here is how these tools are coming out as outputs from geoprocessing tools. So here, if I were to run generalized linear regression, which I did looking at some variables, it gives me a layer as a result, like we're used to, but it also gives me 3 charts. So I have a scatter plot matrix, a histogram, and a scatter plot. If I open that matrix, which is also a new chart type, I'll give it a little bit more space here. We can see the relationships between all these different combinations of variables in one visualization. And I could also choose to visualize these as the R-squared values instead if I wanted to just quickly pick out the ones with the highest R-squared values and the strongest correlations. And also a lot of our clustering tools now require that you have visualizations. For example, the multivariate clustering tool, which uses a k-means algorithm to cluster our data based on multiple variables. The output of the tool is this map that has 4 different colors. So I have 4 different clusters. But for me to understand what those 4 different clusters mean, I need a chart. So it now automatically includes a box plot with that visualization that I can look at in comparison to my map and understand what each of the different groups mean and interact with them across the chart and the map. All right, so now I'll hand it over to Tom to talk about some of our hub stuff.
Thanks, Flora. So I work, as Flora mentioned, I work on the ArcGIS Hub team, and we build our application in JavaScript. I bet there's a few JavaScript developers in here. So what I want to show you this afternoon is just some ways that you can apply some of what Flora's been talking about to your JavaScript development. Now, there are more JavaScript charting libraries than there are like JavaScript frameworks, or than there are types of charts. I mean, there's, no shortage of innovation in the JavaScript data visualization space. And really, and I've used many of them in various projects, and there's not, you can use any of them with ArcGIS. There's not really too many limitations there. But what I wanted to talk about first today is a library called Cedar that we use. It's the JavaScript library that is built into the hub. It's something we've developed, and it's open source. And Cedar's purpose in life is to be a JavaScript chart for ArcGIS. It's not a charting library itself. It is more a bridge between things that we know about ArcGIS, data structures, REST endpoints, and charting libraries. So as you can imagine, it's deeply integrated with ArcGIS. It's really focused on what we know about ArcGIS data structures, and the you can use it by pointing directly to REST endpoints via URL, or you can use it with local data as JSON. We try to bake in some smart defaults. So we read all the white papers that Flora writes, and we try to keep up with the really great work that they're doing over in the Pro team, and keep some of the smarts that they baked in as default in sync with what we have in Cedar. But we are not as smart as they are. So. We also, though, of course, leave a door open for you to override those defaults. So you can pretty much do anything you want. And finally, what we try to encourage in the hub in general, but specifically within Cedar, is to make it so that you can extend the charts that you build, the sort of our charts, and share them with others. If you've got good patterns and working with them, you can save these things as JSON configurations that other people can use. So the process of working with Cedar is pretty straightforward. You have some idea of a data visualization you want to make. You've thought about your data and how your state map needs a chart to go along with it, because it's not very meaningful as it is. You know you have data. You have either features in the cloud or a map. And where Cedar comes into play at first is you build a definition, what Cedar calls a definition, and this is just some JSON. And then you pass that over to the Cedar charting library, which is a JavaScript library that you can install into your application. Thank you, Markham. Markham's creeping up because I'm running against the clock on my battery here, so just hold on to that just in case. Everyone, keep an eye on that power thing up there, and let me know when it gets down to single digits. Finally, after you put this all into Cedar, you get a chart on the other end. So let's just take a look at what that looks like. We'll build this chart right here. As you can see, it's a state chart. And so getting started with Cedar, you're going to install it. You can install it with a package manager like Node or Yarn, or you can go old school if you want and just bring in the script tags. What you notice here is that, as I mentioned before, Cedar's not a charting library itself. It sits on top of another charting library. At this point in time, that charting library is AmCharts. So if you go ahead and install it from a package manager, it will install those dependencies for you, but if you're adding in scripts, you need to add in the AmCharts scripts ahead of time. And so we build that definition, that JSON definition. This is just a plain old JavaScript object, nothing special. At a minimum, it needs 3 properties: the type, the data sets, and the series. So we'll look at each of those in closer detail. Type is sort of what you imagine it to be. It's a string. We have just got a few built-in types that are in the Cedar documentation. And as you can imagine, bar built to bar chart, line built to line chart, scatter, so on. Or you can also provide your own specification. So if one of these, this is where you can extend Cedar, we mentioned, and define a JSON specification that is a bar line combo, let's say. And we can data bind the ArcGIS data to that. And we'll talk a little bit about that later. So the next piece that a definition needs is data sets, and this is where the ArcGIS comes into play. In this case of this chart, we're going to pull that data from the feature service, from the REST endpoint. So we're going to use this URL property here of a data set. And this chart is pulling data from only one data set. So data sets is an array of objects, and in this case we only have one, and we're going to use the URL. And then there's a query, an optional query that you can pass to this that has anything that you can define in the query API. So the aware clause, order by fields, anything that you can do if you're familiar with a JavaScript API defining queries. And then the final ingredient to the definition is a series. So a series, each series is going to represent one of the plots or sets of bars or lines on the chart. And so in this case, we only have a single series, and this is where you define which fields you're interested in mapping. So the category field for a bar chart is what's going along the bottom there, and that's going to be the state name, and the value field is population. And you can define labels and other properties on series. So we need more than just that definition JSON. We need the actual Cedar JavaScript itself. And so that is where we import the chart from Esri Cedar, and we create a new chart at some element. We give it an element ID. We pass that on to the definition. We pass the definition onto that. Now at that point, it's not rendering the chart. You later on, at some point in the life cycle, you can call chart show, and it will fetch the data and render the chart after the data has been fetched. So there's a reference here to, so here's what that chart looks like after it's rendered. You see that it's done some, like we said, some smart things. It's got a tooltip. You can zoom in to see certain areas. It's already sort of scaling. It's handling the labels and stuff on the axes so that they're not overcrowding. And these are all sort of the smart defaults that you can take or leave. And the entire API for the chart class itself is here in the Cedar documentation. So if you want to get deeper into it, you can see how that works. So we are here to talk, it's a mapping conference. So how does, Cedar interact with maps, not just the REST endpoints? The simplest way to work with the map is if you've got the map data already in the client, in the browser, on hand, then you can pass those features over to Cedar so that they don't have to be requeried, right? We don't want to do any sort of expensive network requests if we don't have to. This would be if you're using features in, I don't even think this is a thing now in 4, but 3x snapshot mode. Some mode where you're confident that you have all the features on the map that you need to visualize. So in this case, instead of passing a URL to the data set, you just pass data, and it expects a feature set, which, if you're not familiar, that's the name we have for the thing you get back from a REST request. So feature set has a property called features, and that's all you have to do is specify that instead of a URL, and it will plot those features on the chart. In this case, you can't use a query. You can't pass a query to that to to do any kind of querying or sorting or any of that sort of stuff. You're just going to use JavaScript, right? You've got an array of objects, so JavaScript has feature, sort, already has APIs for that, so you can just go ahead and apply that in the JavaScript code that you have before passing the features over to Cedar. So what that looks like, this chart here is, so we've pulled down this data, the data for the states here, and then we've just passed it over. The chart definition for this, other than having using data instead of a URL, is the same as what we saw earlier. And these are all these will be linked to from the slides if you want to explore the code pens any further and play with the live code. Probably the most common use case for Cedar, and the most common way it has been used in the past or until recently, has been to aggregate, you've got features on a map, but the features that you're seeing on the map at that moment might not represent the whole data set, or really the visualization that you want to do for those features is not just showing each individual record. Like, you probably want to do some summary statistics on them. So take a look at what we're talking about here is this. So here, if we were, we want to summarize these points by state instead of just showing one record for each, or one line for each. So in that case, you can use Cedar as we did originally, use a URL, but we also send, instead of just querying the features, each individual features, we query the summary statistics. And what's great about this is that the summary statistics are, the results for them are very small, not a lot of network traffic. So this is something where you can work with the data that's in your browser in the feature layer, but make several requests and not worry about the payload size back and forth to the server. And as we said before, the query property itself, accepts any valid query parameters that you would send in a REST request or apply to a feature service. So here we go. As we zoom in, on these here, you can see that it's resending queries for these features just to get the ones that are filtered in the view here, and it's summarizing them through the REST request. But nowadays, since last year, we now have in the latest versions of the JavaScript API, we have the ability to do client-side queries. Does anybody use these? These are pretty cool. So now we can work with the data that's in our browser, and then the JavaScript API provides this rich capability to query it, and pretty much the entire query API is supported. You can perform aggregate statistics on the data that's there in your browser. So this is a great feature of the JavaScript API, and it's made that last scenario even simpler in Cedar. So in this case, instead of, we would when we set up the chart, we would use a data property for the data, pass features in. And then whenever we requery the data on the feature layer view using the query features property, we would just handle the callback there and just say, we would just reapply the data, the results of that client-side query to the data, and then call chart render, and it will be refreshed. So what that looks like in practice here is, grab this guy. So as you move this around, all this is happening here in the browser, and no additional network requests are being made. So as you increase the buffer distance or move that around. So that's pretty great. And again, nothing that we did in Cedar, just all thanks to the magic of the JavaScript API. So Cedar does more than bar charts. You might not know that from all the examples that I've been showing. I am not a data viz person. You might not know that from all the examples that I've been showing. So I just go to bar charts because that's my go-to deal. But in the Cedar docs, we show all the different sort of types that are supported in the box. We've been talking bar charts. We, obviously support multi-series bar charts. You can do those as grouped or stacked. Obviously, you can pivot the axes, and by using bar horizontal, line and area charts are also supported. And despite what Flora says, due to popular demand, we were obliged to create a pie chart. We didn't want to, but our customers insisted. We also have scatter. One of the newer features that, what, am I going to print that right now? No. My trackpad got very sticky at lunch. Well, I wasn't using this at lunch, but it got very sticky, so I'm having a hard time clicking. So one of the new features that we've added to Cedar recently is the ability to support coded value domains, or essentially, effectively, to decode coded value domains. So if your fields have a domain, you can supply this. So here, the values in the field are going to be either 1, 2, or 3, and what we're doing here is just decoding those into open or full. So the way that you do that is by just passing in this. You pass in this domains property, and this is actually you actually get this value back from the feature service. So this is something, if you have a feature layer already, this property is already on it, or something you can get from the REST API and just pass it into the Cedar definition. And then Cedar will draw the fields with the correct labels. So as I mentioned, beyond the defaults that we apply with those charts, you can specify overrides to change whatever you want. Every aspect of that chart is customizable, and the way that the language that you do for that depends on the underlying charting library. That has changed over time. In the past, we used a library called Vega. Now at Cedar v1, we are using AmCharts. We are going to stick with AmCharts. That is something that is sort of standardizing around Esri. Multiple teams are sort of gelling around that library. But we'll talk about some more later. But so basically, AmCharts has their own JSON API for configuring a chart. So you can just pass in any parameters here to this overrides, any valid AmCharts parameters, and it will override the chart. So if you go to the AmCharts documentation, you can see how to do basically anything with a chart and apply those changes. That said, whenever there is a corresponding Cedar API, it's better to use that because it will be future-proof if we change the underlying engine or we upgrade from AmCharts 3 to 4, which is on our roadmap. So this area here in these overrides is a little, it's not future-proof. So in this case, we want to use the Cedar's legend visible property instead of the AmCharts legend enabled. So we just take that out of the overrides and we just apply it directly to Cedar. We just talked about decoding value domains. So as I said earlier, Cedar is used in Hub. It's built into Hub, and all the requirements of Hub users is what drives the work in Cedar. So if a customer needs a certain thing, then that's what ends up getting built into Cedar's library. It is open source, as I mentioned. We do take pull requests, and we do, if people open issues, we do work with them to see about integrating that into the library if it makes sense. So inside the Hub, we have the Hub, or also it's also now in enterprise sites. There's the ability to create pages, and you can add a chart card to your page. And when you do that, you get this chart building experience. And so there's sort of two modes to this chart building experience. One is there's this sort of WYSIWYG builder where you walk through, you pick the type of chart, you pick a data set, you pick fields, and it generates the chart. And then the the fallback is that you can just put any valid Cedar JSON into that chart card, and it will render that Cedar chart just as it would in any normal, outside of the hub. So here's what that chart builder sort of looks like. It's just really just a way of picking, data sets, picking the fields that you want to use, mapping them, and setting the sort and filtering properties. Just to give you an idea of what some of the charts that people have built with this. So this is the city of Johns Creek. They've got a page for sort of disclosing financial information so they use these. This would be an example of the kind of charts you can build with that builder, just sort of standard out of the box blue bars that you've seen. But with the customizing ability with the JSON, you can really go to town. And so this is City of Brampton, and one of the things that they've done is they've chosen colors for the chart that match their branding for this particular initiative, and they've just really done a lot of different customizations, having bars and lines on the same chart, and some really nice looking data visualization. So hopefully that gives you an idea of the kind of stuff you can do with Cedar, the hub, and sites. Because the hub is built in Ember, we have a Ember add-on, a wrapper for Cedar that helps you build it, integrate it into any Ember application. So if you're using Ember, this will help. Beyond that, there really isn't anything you need to do to get it into any other framework. It's just JavaScript that you install. There are, we have considered building a wrapper for React because we are bringing it into other projects in Esri that are using React. It's, like I said, it's not needed if you understand how to bring in any other library that works with DOM in React, but it's something that may come up. As far as the road ahead, we talked about AmCharts, and we'll probably be moving to AmCharts 4. Those tooltips that you see on there right now, they're not configurable. They just do a default thing, the sort of the field name and the value. We want to make that so that they're completely configurable, sort of like the pop-up templates are. And events, selection, lazy loading the chart library. That's something that the Ember add-on does for you. Is it handles lazy loading charts, and that's just a best practice with any charting library that you're going to use in a web application. They're pretty heavy, like the mapping libraries. So if you can defer actually even loading the code until someone comes to a point in your page where they're going to see a chart, that's just a best practice. If you use that Ember CLI AMD, that you can do some quick configuration to make that the default, or to make that happen. One of the things what we've talked about doing is taking that logic that we've put in the Ember wrapper and moving it down into Cedar itself. So Cedar won't load the heavy dependencies until you need them. Even AmCharts is broken out into several. It's got several files. One for if you need scatter plots or bar charts, and if you don't need pie charts, you don't need to bring that in. So Cedar could be smart about saying, oh, okay, they've had bar charts before, now they've requested a pie chart, let's go get that library. So that's something that we've taken a good look at how we can do. So that's it as far as Cedar goes, and and what we're doing in the hub. This is a pretty easy way to get your visualizations jump started, but as I said, there's plenty of charting libraries out there that you can work with, and if you have questions about some of the ones I've worked with, I'd be glad to talk about and see, trade some ideas. So.
We have time for questions,
Yep.
if anyone has any.
And I made it without the charger. Thank you, Mark. Yes, sir, in the corner with glasses.
So you showed the Canadian site there where it had the line bar chart. Are you able to do multiple axes as well?
Oh, sorry, I flipped it. You can
Oh.
flip it back.
Multiple axes.
Yeah, let's say if I wanted to do two line charts with a bar chart, and each line chart has a separate axis. They're different parameters, but they do have correlation.
I think that's what's going on here. I see values on the two axes. There's, the values over here for axes, and then another axis here. So
Okay.
I think that's what's going on. Any other questions?
This was built with Esri.
This, yeah. So under the hood, this is built with Ember, but this is not. The people that built this weren't interacting with that. The only interface that they had was the Cedar JSON. No. Sorry, you had to.
Has there been any consideration to creating some charts that are so data-centric, timelines, things of that nature? Really love the ability for a number of our projects just to show a timeline with certain milestones. We click on that milestone, display some other data associated with it.
Yeah, in what context? Like when you say, like, are you talking in like with the JS API or web sort of things, or in Pro or
JavaScript.
in JavaScript? I'm not, in terms of it being baked into the library itself, I'm not sure. The only like work I know that they've been doing is with the pop-ups, the charts and the pop-ups, and we've been coordinating with them on that. But there was a timeline widget before, right? But that was just a picker. Oh, I know what I'm thinking about. Yeah, I know somebody who built a custom, sort of what you're talking about. Is it like a timeline, like the timeline widget that existed in the JS API 3x, but it was actually a chart at the same time, and it was sort of interactive with the data there. But maybe I'm not understanding what you're asking for.
Maybe that's it. I just missed it.
No, that was just, I conflated in my mind something someone did for a custom project with a widget that was built in the JavaScript API. But maybe? Okay, you, sir. Yeah.
Yeah, maybe you briefly mentioned it, but can this be used with both the JavaScript API 3x and 4x?
Yes. Yes. Please rate our session, by the way. She probably already said that.
I didn't.
Yeah. So, like I said in the beginning, there's not a lot of magic in terms of using the ArcGIS API with any library. It's what the difference is. Like with the JavaScript API, you've got these features, and features have attributes. And typically, most charting libraries just expect your data to be just an array of objects, and it's working on the properties at the top level of the object. So that whole mapping of, not just mapping what's in the array, but going down a couple levels down to the attributes to pull the data out is kind of like that's one of the only, that's one of the tricks. It's not hard to do, so if you wanted to do anything with any other library, it's not hard to do. In the back row.
Is Cedar in general going to be like the CS moving all the online applications like ArcGIS Pro?
That's a good question. I'm just going to say no. We moved, in the circles of everyone that's doing, or not everyone, but a lot of the teams that are doing data visualizations, we've been trying to get everyone together and say, hey, how do we bring these things together more closely? It's the products, the different products don't really need what Cedar has. So Cedar sort of provides sort of a higher level API that makes things user friendly, right? And usually these core products are doing stuff directly with the charting library themselves. They don't really need what Cedar has. That said, through all of this, there has been some at least coalition on the coalescence around the underlying charting library, So I'd say AmCharts is looking pretty good. So within Esri. Yes, sir.
Has the Cedar charts ever been tested for file-away compliance?
Yes. In fact, so the hub has to be and sites have to be, and we got to some minimally acceptable level, I don't know what, and then we're actually about to, one of the developers who's not here this week is working on that, on taking it to another level. And I'm not familiar with that, with what gaps he's filling. But the underlying AmCharts library is itself. So what he's going to be doing is taking more advantage of that and exposing it through Cedar. Or probably, actually, he's probably not going to be exposing it through Cedar, but applying defaults that are more 508 compliant than what is there now. We don't have like anything that in the docs that says this is how 508 compliant we are. So, but AmCharts does. Any other questions? No? All right, well, thank you very much. Oh, we have stickers here. If you're into Cedar stickers, even if you're not into Cedar, the logo is pretty cool. So come grab one of those. Let's talk charts and enjoy the rest of your week.